Fireworks are the pretty boys of explosives. They're stuffed with gunpowder and certain elements on the periodic table, and they make nice looking colors in the sky when they explode. Lithium and strontium produce red, sodium produces yellow, copper produces green, magnesium gives off white light. Today you'll learn about the emission spectra, and why certain elements give off colored light when they're burned or excited. Similar to fireworks, in a flame test, various salts of alkali and alkaline earth metals are soaked in alcohol. The mixture is then set on fire, and we notice that certain elements give off distinct colors of light. Strangely enough, this observation led to a better understanding of the atom and how electrons orbit the nucleus and what we know today as the Bohr model. So you might ask, why do atoms give off certain colors of light? We'll just take copper, for example. By now, I think everyone understands what a Bohr model looks like, where you have protons and neutrons in the center in the nucleus, surrounded by electrons, which are found in orbits or energy levels, different rings. So the farther you get away from the nucleus, the higher the energy level. So what happens is, as electrons absorb energy, they're going to jump outside. They're going to jump farther away from the nucleus. Now, as the electrons lose energy and they release energy, they actually fall back towards the nucleus to a lower energy level. And in the process of doing so, it releases colored light. So if you look at the looping image in the center, you can see how as that electron falls back towards the nucleus, green light is emitted. And that's how copper gets its green color as it burns. Let's talk about the different types of spectra. You have continuous spectrum, emission spectrum, and the absorption spectrum. A continuous spectrum is produced by any source of light. It could be a light bulb, it could be the sun, but what it's doing is it's passing off white light. And when you pass white light through a prism, you can actually see the whole range of colors. You can see all the colors of the rainbow because all the wavelengths of light are given off. An emission spectrum is produced when you have a hot gas and its light is passing through a prism. It leaves certain little marks and fingerprints, we call it. It identifies what kind of element or atom is giving off this light when it's excited. In an absorption spectrum, cold gas absorbs the light from a continuous source before it passes through the prism. So what happens now is you still have a continuous spectrum, you still see most of the colors in the rainbow, but now there's little black lines, and those black lines indicate the wavelengths of light that were absorbed by that gas. So now you can use the black lines, they're almost kind of like the fingerprints in the emission spectrum. You can use those fingerprints and you can identify what type of gas it is. It's through the absorption spectrum that astronomers can figure out what elements and what gases make up the atmospheres of faraway planets and faraway stars. They can actually just examine the absorption spectrum, look at the black lines, and then they can make an educated guess as to what elements are in that atmosphere. With the naked eye, I can just see white light, but these lenses act like a prism and it breaks down the individual wavelengths of light. So here I have a continuous source of light, it's a light bulb, and that light bulb gives off white light, but what we don't see without these lenses are the individual wavelengths. So now that I'm wearing these special glasses, I could see red, orange, yellow, green, blue, indigo, violet. When you mix all those colors without the lenses, I would just see that as the color white. So this is known as a continuous spectrum. I'm going to demonstrate to you the emission spectra of various gases. And how I'm going to do this is I'm going to use a discharge lamp, which can hold a tube containing gases. I'm going to show you 3 different gases, starting with mercury first. So when I turn on the electricity, the current runs through the gas gets excited, and it gives off colors. And then I'll show you what it looks like with my lenses on. The first tube I'm starting with contains mercury. And with the naked eye, I could see that mercury gives off a bluish colored light when it's excited. With my lenses on, let's see what we observe on the emission spectrum. So I see predominantly green and blue lines, and there's also a faint yellow line. And if you look above me, the emission spectrum matches up with what I see with these lenses. This is neon, and normally without the lenses, neon is a blood orange color. And the emission spectrum, I could see red, orange, and yellow lines. So that would make sense because it's the sum of those wavelengths which gives you the blood orange color. Let's check out hydrogen. So with the naked eye, I notice that hydrogen gives off a purple color. And with my lenses on, I see that hydrogen now gives off 3 distinct emission lines. I see a red line, there's a light blue, and there's also a deep blue line. So the purple color that you see with the naked eye is really just the sum of those wavelengths put together. So let's try to put this all together and summarize what we just learned. So you saw how certain elements and atoms give off colored light whenever they're excited. And the reason why this happens is because we speculate the electrons are arranged in different energy levels around the nucleus. As an electron absorbs energy, it's going to jump farther away from the nucleus to a higher energy level. Now as they cool off and they lose energy, they're going to fall back down to a lower energy level, and in the process of doing so, they emit energy in the form of light, colored light, which corresponds to the emission spectrum. The emission spectrum is different for every element. So for example, copper, when it gets excited, emits green light. Sodium gives off yellow light. Lithium and strontium, red light. So the emission spectrum can be thought of as almost like the atom's fingerprints. It's kind of like how you have your own individual set of fingerprints, and we can identify who you are based on just looking at them. Well, to a physicist or a scientist or a chemist, we can identify an atom or an element just by looking at its emission spectrum. The emission spectrum has specific lines that tell you what wavelengths of light are given off, so then I can identify that particular element based on just looking at its colors. I hope this makes a lot of sense. This will help you as we start going into electron configurations and how we start studying how the electrons are arranged around the nucleus in the next topic. Thanks for watching, and I'll see you next time on Win Chemistry.